Now let's look at the 5-number summary. Okay. The first number is the smallest value. The second is first quartile, Q sub 1. The third one is the median, Q sub 2. Fourth one is Q sub 3, and then the largest value of the data set. So it gives you 5 specific points in the data set when you arrange the data from the smallest to the largest. And this is called 5-number summary. And if you take this 5-number summary and plot it, then it'll give you a visual representation of the entire data set, and you can get a visual idea as to whether there is skewness or not, whether it is all tightly packed or there is variability spread out from smallest to the largest. So you get a complete understanding of the data set with this 5-number summary and the corresponding plot, which is called the box plot. Now, box plot looks like this. So here is an example of a box plot. Now, here the box plot is drawn horizontally. Okay, in the Excel exercise that we will be doing, we will do it vertically. Okay, you can do it either way. It doesn't really matter how you do it. So there is the midpoint here. So this is your median. And then this is Q sub 1. This is Q sub 3. And you draw a box. The height of the box doesn't matter. So don't make it too large or too small. Okay, it's a reasonable height. Or in our Excel example, it will be width, because we will do it in a vertical fashion. So these are the 3 numbers in the middle of the 5-number summary. And then you have the smallest and the largest. And the smallest and the largest are plotted, and then they are connected to the box with this dotted line or a solid line. In the Excel example, you'll see solid line. Now, these are called whiskers. So now when you look at this plot, you see that the smallest to the largest goes from here to here. The mid 50% lies here, and there is a large skewness on the right side. Then you see the midpoint is here. The smaller 50% is kind of packed together more tightly than the larger 50%, and the difference between the median and Q sub 3, the third quartile, is larger than the first 2 quartiles combined, and then the difference between Q sub 3 and Q sub 4 is even larger. So all of this information can be readily understood when you look at a box plot. That is the power of box plot. Now when you look at 2 variables taken at the same time, you can compute what's called covariance and correlation coefficient. Now, covariance is a stepping stone to the next step, which is the correlation coefficient. And we have formula for covariance. Covariance measures the linear association between 2 variables. If there is positive association, you will see a positive number for covariance. If it is a negative relationship, you will see a negative number for covariance. And this is the formula for sample and population, but we won't use these formulas. Now, correlation is a measure of linear association between 2 variables. It is not about causation. Just because 2 variables are highly correlated doesn't mean that one variable causes the value of the other. You can only say that there is a relationship between the 2 variables, and the formulas are given like this: the covariance between the 2 variables divided by standard deviation of x and standard deviation of y. So it can be for sample or it can be for population. Now what does it mean? Correlation coefficient is a value between -1 and +1. A value closer to 0 would mean correlation is pretty much absent or very weak. So correlation closer to +1 or -1 means there is strong correlation. The correlation between the 2 variables is strong. So it can be both positive or negative. So the sign of the correlation coefficient gives you the direction, whether it is positively correlated or negatively correlated, And the absolute value of correlation coefficient gives you how strong the correlation is. The strongest possible is when they all line up on a straight line. If all the points line up on a straight line, then correlation will be equal to 1. If it is a positively sloped line, the correlation will be +1. If it is negatively sloped line, then the correlation will be -1. The farther the points go away from a straight line, the weaker the correlation will get, and the correlation will become closer and closer to 0.